Hey everyone, today we're jumping into the world of vectors. But listen, this isn't going to be your typical dry math lesson. Nope. Think of it more like a story. A story about the incredible power of having a direction. It can seriously change everything. So let's get right into it.
So, I want to kick things off with a pretty big question. One that goes way beyond a textbook. Is just working hard, grinding it out, putting in the hours, is that actually enough to get you where you want to go? Or is there a key ingredient missing from that whole equation? This is really the heart of what we're going to explore today.
And that brings us to this, the difference between just hard work and hard work in the right direction. See, one is just raw effort, pure energy. The other, that's focused, it's smart, it's got a purpose. And right there, that idea, that's the fundamental difference between what we call a scalar and a vector.
Okay, let's break down the first piece of this puzzle, a scalar. A scalar quantity is really just a number. That's it. It only tells you about the magnitude, the size of something. So if you say, I studied for 10 hours, or I ran 5 kilometers, that's a scalar. It tells you how much, but it gives you zero clue about where or which way. It's all effort with no direction.
Now, here's where things get really cool. When you add that missing piece, direction, you get a vector. A vector has both parts. It's got magnitude and it's got direction. So now, it's not just that you ran 5 kilometers, it's that you ran 5 kilometers north. See? It's a much more complete, much more useful piece of information. This is what focused work looks like. It gets you exactly where you intend to go.
And visually, we've got a super simple way to show this. An arrow. It's kind of genius, right? How long the arrow is, that's your magnitude. That's the amount of force, or speed, or effort. And of course, the way the arrow is pointing, well, that's the all-important direction. Just two simple parts that, when you put them together, create an incredibly powerful tool.
To really get a feel for how we talk about direction in a 3D space, we're going to use this amazing visualization. Seriously, do this with me right now. Look around the room you're in, find a corner. Got one? Okay, that corner, right there, that's your origin. That's the starting point for everything we're about to map out.
Now from that corner, imagine 3 lines shooting out. The one that runs along the floor on one wall, that's your x-axis. We call that direction I. The line running along the floor on the other wall, that's your y-axis, or j. And the line going straight up from the corner to the ceiling, you guessed it, that's your z-axis, k. And just like that, your room is a perfect 3D coordinate system. These 3 directions, I, j, and k, they're basically the alphabet for the language of vectors.
All right. Now, within this new language, there is one concept, one idea that is the absolute, undisputed star of the show. I love how the source material puts it. It's the Shah Rukh Khan of vectors. And we're talking, of course, about the unit vector.
So what's the big deal? What makes the unit vector so special? Well, its job is incredibly simple and pure. Its only purpose is to point in a direction. That's it. It doesn't care about size or length. In fact, its magnitude is always, and I mean always, exactly 1. It's just pure, unfiltered direction.
And the best part? You can spot one from a mile away. How? Just look for the little hat, or cap, sitting on top of the letter. If you see a little arrow, that's a regular vector, with magnitude and all that. But if you see that cap, that's your signal. That's a unit vector, a pure signpost, just showing you the way.
And, the really great thing about this whole system is that doing math with it, like adding vectors, is surprisingly easy. You don't need some crazy complicated formula. You just combine the matching parts. You add the i's with the i's, the j's with the j's, and the k's with the k's. It's that simple.
Just take a look at this example. We've got vector A and vector B. To find out what A plus B is, all we do is add the I parts, 2 plus 1, which gives us 3i. Then we add the j parts, 3 plus 4, to get 7j. And last, the k parts, 1 plus 5 gives us 6k. That's it. You're done. Pretty straightforward, right?
Okay, so we've talked about what vectors are, what they look like, and even how to add them. But let's circle all the way back to that first question we asked. Why does any of this actually matter? Why is it so important to understand vectors? Not just for a test, but for anything you want to achieve. Because when you get right down to it, vectors are all about strategy. They give our hard work a clear direction. By focusing our magnitude, all that effort, in one specific direction, our efficiency just skyrockets. We stop spinning our wheels and wasting energy, and we start to see a clear, direct path from where we are to where we want to be.
And that, right there, is the ultimate takeaway. It really brings everything together perfectly. All the hard work you can possibly do is just a scalar. just a number, until you give it a purpose. But the moment you add that direction, you create a vector. And as the source so powerfully reminds us, if we have the right direction, we will reach our destination. There's no doubt about it.